I'm going to be talking about social code analysis and what that means in all this as we go along. At IIT Madras, I teach a course called Tools in Data Science, and one of the projects that I assigned the students was you got to write a Python program that automates data analysis. And when we get a data set, it has to use LLMs to analyze that data set and create a story all by itself. The evaluation and the feedback were also LLM based. We had sort of 27 checks. For instance, item number 17 was the code should only send carefully chosen analysis to the LLM, not the whole thing. And the evaluation was done by an LLM, which in some cases told the student, yeah, look, you're only sending selective analysis, that's good, or no, you're sending all of it, that's not particularly good, etc. But this wasn't the fun part for me. What was more interesting was another experiment that I was trying, which is how exactly does copying work among students? In this course, copying is not only allowed, but encouraged. The project specifically says you get 8 bonus marks for code errors. For your base marks, you're welcome to copy. But over and above that, if you produce something that's unique, we'll give you bonus marks. So effectively saying, yeah, it's good to create original stuff, but please feel free to work together. And if you want to freeload, that's perfectly fine. That's all right. And what I did was evaluated the code similarity between students. Specifically, the way this was done was take all the submissions, remove all the fluff, the comments, the doc strings, and tokenize it, take chunks of 5 tokens and see how much they overlap. And based on this, what we found was, here's what the similarity looks like. So each of these is one student's submission. And at 100% threshold, here are a bunch of students whose submissions were identical. 0 difference. And here's another bunch whose submissions were identical. Here's another bunch whose submissions were identical, and so on. The color indicates something that I will explain later. The size represents the marks that they finally scored. So some clusters are bigger because the students in that cluster scored higher. Some clusters are smaller. Now, even though students have copied responses identically, they don't necessarily get the same marks because the LLM is evaluating and there's a certain amount of randomness in that evaluation. How we manage that is a different story. But the thing is, across this, by the way, and what I also got to see was at different levels of similarity. So that's at 100% similarity. But if you look at it, let's say at around maybe 80% similarity or 70% similarity, a larger cluster forms. So here are a group of students who kind of copied from each other, but it's not identical copy. It's almost like there are 3 clusters of students who probably gotten the same idea. I'm not sure if it's independent or if it's emergent, but there certainly seems some commonality across those solutions. And we get to see what the nature of that commonality is. Of course, at some level, there are huge differences, but we'll go to that in a bit. Now, one of the things that I saw was the way in which the timing of copying. So for instance, there was one student who submitted the original, and I know this is the original because it was the earliest submission, on December 11th, and they scored 7 marks. So the first copy that was made of this submission was a day later, the next day, the evening, on 12th December evening. The second copy was made 2 days later in the night. And then there was a spate of copies that happened right before the massive. On another cluster, somebody put in an original late night on 12th December, and then on 14th December afternoon, the first copy arrived. And then there were several copies just minutes or hours before the deadline. Now, the interesting thing is that the students copied from the first one, which was submitted on 11th December. On average, they scored about 7 marks. The ones that submitted from the second cluster, on average, scored about 10 marks. Now, the second cluster was significantly better than the second original, was significantly better than the first original, partly because it was a loose copy of the first original. By looking at the code, it was obvious that the second original student had, well, I call them original, but semi-original, close enough, had taken enough good elements from the first, incorporated it into theirs, and then put it in. Which means that all of the students who copied from this late submission benefited from the wisdom of the crowds. So a good rule for students is, if you're planning to copy, copy late. It's a good strategy.
That's a bit oversourcing.
Yeah, exactly. And the amount of trouble that I have teaching people who enter the workforce, look, it's all right to copy. I just want you to get the job done. I don't want you to produce original stuff. Just get it done. But now some students make sensible changes. So here was one on the left, there's the original. This student added Python.env and a few other related minor changes to the original code so that the API key is taken from the environment. Makes perfect sense. Another student made a similar change. They took this line and replaced the actual API key from their environment, effectively leaking their own API. I mean, why would you do that? Among other things, that lets every other student use and exhaust your API key limit. So the second rule is, if you're changing code when you're copying, make sure you know what you're doing when you're changing it. Try not to mess it up. Otherwise, just submit the same thing. It's fine to get points for originality, but you lose points for something like this. What I also realized was that roughly half the students put in original submissions. That is, now I have a measure of similarity, which is, let's say, about 50% Jacquard similarity. That is, if I see pieces of code that look like what you see on the left versus the right. Now, the left says you are a data analyst. The right also begins with you are a data analyst. Right? The left says, given the following data set information, provide an analysis plan. Second says, provide a detailed narrative based on the following data. Yeah, kind of similar. But this is the threshold of what I consider distinct submissions. Anything closer, it becomes a copy in my crude definition. And this is at a 50% Jacquard similarity. At this level of a cutoff, what we find is that half the students neither copied nor allowed anyone else to copy from there, despite them being clearly told that copying is allowed. You're welcome to work in groups, collaborate, do whatever you want, and yet half of them choose to work in isolation. Now, what this implies, however, is that they have a disadvantage. I had students broken into 4 groups, and that's what the colors represented. The standalones, they didn't copy, they didn't allow anyone else to copy. And on average, their score was about 6.23, the lowest performer. Those who did slightly better were the ones who copied early. The first ones to copy as soon as someone publishes it. And this, we know, is not a great strategy, because if you wait till late, you get a better pool of submissions, and therefore those who copied late did a little better. But the people that scored the highest were the originals, meaning people who put in something by themselves, but more importantly, others had copied from them. That's where they had gotten, I'm guessing, the maximum benefit, because somebody or the other would have said, oh, this didn't work for me, or that, maybe you could have done it this way. And that feedback really helps them improve. So from my perspective, I see this as a win in 2 ways. At the very least, if you're really tired, if you've got 100 other things to do and my course is just one among a dozen, it's all right, copy. It's better than nothing. On the other hand, if you are putting in some good work, then you can get a bigger boost by letting others copy from you and learning from each other. So those were the lessons of students. But as an educator, there were a few other things that I learned. First is that there's a lot of stuff that I can learn by analyzing similarity of code. I can figure out who are the students who are isolated, and therefore I only need to connect them together. Who are the students who are future teaching assistants? And I do need a bunch of teaching assistants, and this is a pool that I can pick from. When do they learn? how close to the assignment deadline do different people learn. The curve helps. And as you said, scale is a nightmare. I love scale because what that allows me to do is run large scale experiments like this, and we get a beautiful curve of the distribution. We get to see what are the concepts that they are tweaking and messing up. What are the concepts that they are copying and doing it right. So a slightly better understanding of where the learning was effective and where the learning was not so effective. In short, I have only one message to leave everyone, which is looking at the similarity of code submissions can be a very powerful thing. Do try it out, and please do share what you learned from it. Thank you.
My question is, why choose that particular method?
Why should that recommend?
Jaccard similarity.
I
Is there any
tried.
rationale for that?
Yes, I tried 3 techniques. In fact, the first which I had announced in the project was I would use embedding similarity. It did not work well because chunks of code that were, so if somebody had taken roughly the same kinds of words but put them around in very different ways, the sequencing information was lost, which Jaccard similarity preserved. Jaccard similarity is also more explainable. I'm just saying I'm taking phrases of 5 words and overlapping, and the explainability becomes important with the difficult students who come back and say, no, you should have given me more marks. I didn't really copy from the student, that sort of thing. So in short, sequencing, preservation, and explainability.
For the benefit of the prof, we could explain a bit about Jaccard similarity.
Sure. It's looking at, firstly, you will be able to see the code, but this is what I did. I took the code without any of the comments or doc strings, and then tokenized it, meaning converted the Python code into words. If it had an open bracket, open quotes, if you have a function call, all of that gets converted to words. So now it's roughly English. And then I took all phrases which are 5 words. So take the first 5 words, the next overlapping 5 words, next 5 words, and so on. And these are chunks. Then I take all of the chunks in program A, all of the chunks in program B, and see roughly what percentage of overlap there is. That's the Jaccard similarity. I guess.
I'm trying to understand the exercise that you give the students. So if someone submitted early, are they allowed to look at what other people did with their code and then resubmit later after questions?
Yes, so students can do whatever they want until the deadline. Actually, they can do whatever they want even after the deadline. I just take it, throw them a copy.
So they can also use generative AI tools.
Yeah. So in this course, everything
And
is allowed. They are also welcome to pay somebody to take the course on their behalf. Well, the thing is, if they're able to do that here, then maybe they're able to do that in the workforce. I don't mind having them. Get the job done.
The ones who allow others to copy, right, did they get a chance to improve and prototypes? Are they allowed to edit their submission?
Yes, so they are allowed to make changes right up to the point where I'm taking a copy, which is the assignment deadline. So many of them had submitted, so to speak, 3-4 days before the deadline, and had possibly even shared amongst each other well before that, and we were happy to that. And yes, there were comments after they had put in the submission. That's they just put it into their GitHub repository. All they have to do is send a link to the GitHub repository and they keep taking changes. It's the tools in data science course. The link you can get all of the links from up here, and it's part of the bachelor's in science.
But I have given over an example that I have sort of similar information. I wanted to know what kind of a course you do.
Change notes and publish.
Okay, thank you.